Merlin, Network Magic, SmartNet Total Care, Microservices. Okay, everybody, let's get the whiteboard out. My name is John Capobianco. This is something I've done and do in a production environment. I'm just moving it into my own personal open source project to move it into containers and then move it into Kubernetes. And then eventually when my environment at the real world in production catches up with this cloud Kubernetes craze, we are spinning up Kubernetes in production very soon. I'll be ready to go with some network magic. So let's get the whiteboard of doom out. And I'm going to highlight some services you might not know you have access to. I think this is a very important video, not just about the cool, fun technology, but making you aware of some services that you should be tapping into. All right, so here's the idea here. I'm going to use PyATS against this Nexus 9K in the sandbox, and I'm going to parse, meaning transform, show version, and show inventory. We're going to focus on show version, but also show inventory. And using the keys, using the JSON key, we can pick keys from this JSON, and using requests in Python, post them to SmartNet Total Care cloud services provided by Cisco. That then we're going to take that more JSON, right, the JSON response, run it through our Jinja 2 and create business-ready documents. Then we're going to put the whole thing into a Docker container and then as a Kubernetes pod that can run every minute, every 30 seconds, however the cadence you want. And you're going to see why that becomes important. We're going to add real-time, little real-time robots that can help us ensure the security and the fidelity of our networks. It's going to sound too good to be true, but let me show you this through this video, the progression. And at the end, we're going to have a little microservice in the cloud that every minute goes and gets the version of your device and the inventory of your device, sends them to the cloud, creates business-ready documents with intelligent, actionable information as PyATS tests. All right, so let's take a quick look here. What's the inspiration for this? I've been doing this for a very long time with Ansible. I started with, right, this is up in the cloud. It's published by DevNet Automation Exchange. I had some help from Francois Daigle and Devin Sloan. And we've documented everything you need here. So start with these links: the Support API, the Services API, and the Product Security Incident Response Team. Those are our three APIs that we're going to go after. Let me go back to the whiteboard here real quick. And what are we able to do? What are we able to connect from this SmartNet cloud? Well, there is three that I think are very vital to every organization. One is the recommended release. We'll just call it RR. And that takes this version and checks it and says, is this or is this not? My logic. It would say, this is the recommended release of the iOS you're running or the NXOS you're running. Based on that version, here's the recommended release for that platform. We then add some logic and compare it to the version we've captured and say whether or not we are running the gold star, as it's known, recommended release at scale for every device every minute. They change this recommended release because of a bug or a flaw or something they want to promote. And Cisco does this often, and you have to subscribe to email notifications right now for every platform and every device, or have something like Cisco Prime be cloud connected, right? How do you maintain knowing that your whole fleet is running the recommended release? Well, we can do it this way. The other one is the serial to contract. Now, this one I'm going to put a star. I'm not able to do this publicly with the cloud because my Cisco account is not connected to this Nexus's service contract. I'm not privileged to that, right? But we can do a similar thing and send that serial number information against the SmartNet cloud and get our contract information at scale. Now, the security-minded people are going to love this, and I love this. There's the product PSIRT, Product Security Incident Response Team from Cisco. And they do that. They respond to security incidents and make it publicly known, disclose open vulnerabilities. So again, we can take this information from PyATS and send it to the cloud and get back a vulnerability report. And we can then add logic to say if the vulnerability is above a certain thing, make the HTML red, or send an email, or make a phone call. You've seen that. Whatever you want to do with that is up to you and your organization. But let's start by getting it and making ourselves aware of the security posture of our network, particularly public-facing devices, those routers that have public IP addresses, anything that communicates with the public, even internally. We know internally is a threat. What is the security posture of our Cisco fleet at scale, up to the minute, with then actionable things downstream? We also send this report into a SharePoint library. It has its own microservice. Someone can just check a URL and get the state of the network in terms of its security posture. So again, we start with this Ansible playbook, and this is available if you want to do it with Ansible. All the instructions are here. Today I'm going to take this Ansible playbook and turn it into a PyATS job. But first we want to go here. You want to go here, and you want to make sure you're logged in with your account and follow the instructions that I've provided you and follow the cookie crumbs they give you. You want to follow SmartNet Total Care. You're going to need to work with your Cisco administrator, whoever has the contract, the keys to the API, to give your CCO account access to these APIs. So if we click SmartNet Total Care, it will bring you to this overview and what are the support APIs. If this is new to you, if you have not been exposed to this, I would recommend exploring this documentation. For the sake of this video, I'm going to be going into the APIs, and they have the references here. Here's the software suggestion API, and everything you need to know about it, and the URI, and the parameters, and everything it's going to give you back as JSON. Now this is what my API console looks like. I can't click on my APIs and keys because it will reveal my keys to you. And I have to be very careful not to put my keys into the repository or into my container images. So that leads me to my next thing before I get going. I am and I am not able to make these particular images pre-canned and ready to go. What I can do is provide you the base image, the Docker file, the variables in the Python that you'll need to replace with your SmartNet information. Then I will give you the command docker compose up SmartNet software suggested whatever the name of the image is, and you are going to need to build that and store it in your own repository with your keys, meaning your Docker hub. Now you got to be careful. You probably don't want it in your Docker hub because it's going to have your keys in it. Keep these images local once they are built. Don't have any CI/CD trigger to build them in the cloud. Don't accidentally push them to the cloud. They are going to have your keys in them, so be very careful. And those keys will be exposed in the YAML. You can find them very easily. That's a very strong caution to myself as I build this and make it available. Again, the README will have a subsection in the README file for the Docker and the Kubernetes on how to, compose and build your own version of these containers. I can't just publish them because they will have my keys in them. So I'm going to build them. I'm going to transform those Ansible playbooks and what I have already in PyATS into container images and Kubernetes pods and services and deployments. So let's get going on that. Thanks again for sticking around for these introductions. I've had some feedback that people find the whiteboarding and explaining the high level and going through this at the start to be valuable. If you have other feedback for me, if you'd rather me not do all of this and just get right into the code, I'm trying to make this consumable and enjoyable. So just let me know. I'm open to feedback. Anyway, let's get into it. All right, I've got everything working with the PSIRT report and microservice, and let's explore how I've built this from start to finish. Now, I always like to start with documentation, if you can believe it or not, but this is the service I'd like to tap into, the Cisco Security Advisories. All right, and they have all these different CVEs and different impacts and when they were updated in their version, and you can expand them and get different information. Now, can I get this information RESTfully through an API? Well, I sure can. And I want to highlight that Cisco has this product security incident response team, right? Protection, security, transparency, and we're going to see all of that today. But right, they're notified of an incident. They prioritize and identify resources, coordinate product impacts and assessment and fixes, and then the customers and public are notified simultaneously. So this is right the benefits to this service, their policy, and some different contact information. Now at the bottom here they have the API link, which we're going to look at. Now they have this, right, if you just go to the developer side of PSIRT, they have the open API and everything you'd want to know about this API and how to get started. Now in the reference guide, I've jumped right into, right, given an NXOS standalone software version. And it's this simple. I'll show you how you can do this. They have the example of that version there, and I'm going to have the version from my device, right? So I move into Postman, is usually where I start with API development. And what you'll see here is I have a PSIRT collection, and I first have to go get a token. And now that may be an expired token, but this is the Cloud SSO Cisco.com token auth to service. And I'm not going to show you my authorization, but I get that from that API portal after I set up an API service. Gives me a username and a client secret, and I use those to go request my bearer token. Now I copy this token in, and now I want to go against, now let me put the token in. I want to go against the API, the security advisories for NXOS with my version that I've got manually from a show version command of 935. And if I hit send, you're going to see that I get all those advisories back, and I can follow these links to the XML that gives me more details if I want. And I have, every vulnerability for this, and I can collapse them and look at, the bug IDs. I can follow. There's everything you'd ever want to know about these vulnerabilities. And it's a fairly large file because this, is a cloud sandbox, and right, we can see all these different vulnerabilities. So can we move this into a microservice? And I'll show you what I've done here. This is my microservices page, right? The DevNet Nexus 9000 services. We have our learn features, our parse show commands, our PyETS tests. Well, now we have our SmartNet Total Care. When the link takes me, I'm not going to spoil you. I'll show you what the link does after we explore the code. So quickly, I have an API credentials YAML file that I'm not going to click on that contains my YAML credentials. This is the file you're going to have to update with your credentials before you build your container. I'm not going to publish my credentials. Now, the rest of it, I have a Docker file for PSIRT that looks like this. I call from my base image because I know my base image has everything I need for PyETS to run this as tests and do everything else I need this job to do. I copy in my Jinja 2 template. I copy in my credentials file. I copy in my test bed that describes, right, the test bed is this file that PyETS uses to connect to the device and handle all the authentication and stuff. I copy in my Python code, which we'll look at in a second, my shell script that I'm going to run at the end of this, right, as the little image. I want it to run a shell script when it turns on. I'm going to copy in all the files that are created by, right, or my folder structure and my style sheet. Now from here, let's jump into the shell script just to show you what it does. And the shell script is just 2 lines of code, 3 lines. The job that we'll look at next, right, my PSIRT PyETS job, copy in all the results of that job into the HTML, the web server, and then start the Apache web server. Now the Python, I don't want to say it's very difficult at all, and there's probably better ways and better Python available, but the key here is requests because we're dealing with APIs, and JSON because we're dealing with JSON. And I'm still using PyETS as my framework, even though I'm not really using PyETS learn or parse or anything. I like the framework it provides me to run these as tests, pass or fail. My Jinja 2 so that I can have my templates and then my general functionalities so I can parse that show command. Now I want 3 files. There's my little file type loop, my template directory, and now here is my PyATS AE test setup where I connect to my test bed, and then for each device in the test bed, it's only one, but this is a loop. Go ahead and parse the show version command, and then using the specific key here, let me find it. Right, so for version and value in that parse JSON.items, go get the value of software and version. All right, now I print that to the screen here just as an artifact so we can see that we're actually sending the version. And I've made that the variable. So this works if we upgrade the version, right, as the device version changes, we're going to feed it in the version that is actually running and discovered and parsed. The rest of this just creates the files and copies the files into the HTML index, so we have a web page as a home page. Now if we look at the template, you probably might be interested in seeing the Jinja template that I've made for PSIRT. They're under the API folder in templates, and here's the PSIRT template. And it's not that complicated. In the JSON that we get back from the REST API, it has an ID, a title, a bug ID, the CVEs, the base score. Anyway, and this is what puts together the HTML page. And then at the bottom are just my anchor points to the actual output files and a link back to the home page. So let me make sure that I don't think anything is running right now. It's running. Well, let me stop it and start it again. Let me destroy this. Are they both running? Yeah, let me stop them both. I wanted to make sure that this was working before I did the demo. So now let me get rid of them entirely and show you what you are going to need to do. Right, so the home page will be available, and that's something I can publish. But the PSIRT is, right, it's not going to have credentials in it. You're going to replace the credentials with your credentials, and then in the folder that you get clone with Docker installed, you're going to run, and I'll do it with no cache. You don't have to do the no cache yourself. But we're going to build no cache and then PSIRT. Now you may have to say, my Docker repo / whatever you want to call it, utilities : PSIRT, right? When you build this, you should specify your Docker repo that you're going to hold that image in, because it's not going to let you push it to my repo. But for me, I just say PSIRT here because it knows to reference it in the Docker build file. And maybe I'll do that, and let me show you that. In this Docker build file, the Docker compose file, excuse me, where I have this recommended or PSIRT and recommended release, what I'll likely do is put, your repo here inside of something like this, so that you know when you build it not to build it and try to point it to my repo. I'll make note of that. So now let's, it's built, and my home page. Let me bring the home page back up. I don't know why I stopped that. So now let's bring it up, right? So we've built it, and now we're going to just say up, and we're actually going to watch it run. This is pretty interesting. I like this. So again, it's got to get an OAuth 2 token using the username and secret that we feed it. It's running the show version right now. That's the parse show version. Everything. So let me back up here. I'll remove this printout, but it's actually printing out what it's learned. I'm going to remove that. But here, right, we can see that Unicon and PyETS is connected and set up. It's right section parsing show version. So here's the show version, and there is the version we want to feed the API, which we're calling the API, we're storing the data. So here, remember I said I print the version. So there, I'll leave this in the printout, but I'm going to get rid of this big dump out here. But that is what we're transforming. Everything you see here is what we're storing into files. Now, why I use PyATS is because I like this little framework. Step 1 passed, Step 2 passed, and Step 3 passed. And now the Apache server is running. So let's go look at our home page. Here's our home page here. And let's go to the Product Security Incident Response Report. Well, look at it is the PSIRT report as an HTML page. And you can see that the base score, it looks like maybe they're sorted on. No. Okay, because 4.3. But they must be sorted on ID or something is sorting them. But anyhow, we can see that we are vulnerable. This device has all of these open vulnerabilities. Here's the detailed URL for each of them that we can we can do this. And maybe there's a way for me to make them clickable. Right, so there is that report. Let me see about enhancing this and see if I can making these clickable URLs. That's what I'm going to try to do. That would be cool. Anyhow, it's critical. It's 9.8. And then at the bottom, we have the raw JSON, which I'll show you why this is important. And then we have the YAML version of it. Right, pretty cool. Nice YAML dictionary of all these things. If we want a data model. The CSV file. It's going to download it, and I'm going to, if I open it, it's going to open up a notepad. But right, let's bring that into a real tool and open it with VS Code and then put our preview on. Now I can sort them by base score. Show me only so there's only critical and mediums. I'm only care about criticals. Right, all of this wicked stuff. Vulnerable, the bug ID. All of this great information as a CSV file and as a JSON page and a markdown page and all this wicked stuff. Wicked, wicked, wicked. So, and now I can go back to my services list and go back to PSIRT. Now, this is Docker, and I'm going to make this a Kubernetes manifest that will run every single minute. Go and get me the latest. We can patch the device. It will refresh this. We can, as new vulnerabilities come out, we'll know up to the minute that we're vulnerable. Now let me show you why I mentioned the Postman, or excuse me, why I mentioned the JSON is because we can take it into Postman. So you can see here I have the Merlin JSON as a request, pre-staged, ready to go. I hit send. I don't need to get a token. I don't need anything. My robot is doing all that for me, but I have this microservice behind this port ready to go for me. And what's neat is in Postman, I already showed you this, but we can follow the links. So that microservice works as an HTML page. It works as a Postman API. Pretty incredible. So before I get a little reminder to myself, I have to make those hyperlinks in my Jinja 2 template. That's going to be wicked. And then I have to do the recommended release, which I'll do next. So that we'll have a PSIRT report and a recommended software release report. So stay tuned. Recommended release is next. I'm going to do this full tour for that API next. And I'm going to see about adding hyperlinks before I move on. Thanks. We'll see you soon. Hey, so after our little chat and discovery, I just couldn't help myself. So I've jazzed up the, let's look at the code first. I went into the template, right, our PSIRT template, and you can see a little more here. So I've added a little logic. Let me break down the logic and see it here. It's just an if and an else if. And let me tab that in so you can see the indentation here. And then another else. And then I close that with an end if, and then I close my outer end if. So basically I'm saying if the advisory base score is greater than or equals to 8, make the background color of this cell, right, the TD style, background color, let's make it red because it's above an 8, and that's a dangerous score to have. Else, if it's greater than 5 and it's less than 7.9, make it yellow. That's a warning. Else, meaning it's less than 5, go ahead and make it orange, right? It's not quite yellow and it's not red, but it's still an orange. And then what I noticed is that I'm getting an advisory publication URL. Remember I showed you that, and it was the full URL, and it wasn't a hyperlink though. Well, I've just added an href, and then I set it to that variable, and I'm just saying publication URL inside of that cell. So now I think I've brought this up now. Let me just check. So, and oh, here, let me stop. Let me build this with no cache, because I've changed it where I'm not printing that to the screen anymore. So let's bring it up again, and all we should see is the version dump. I do still print the version so that it's handy, and we can see what right there, 935. And now it's up and running. And now let's take a look at it. So if we go to the products, right? So now visually it just jumps out at the consumer that we're vulnerable here. And how vulnerable are we? Well, it ranks from a yellow, an orange, not so vulnerable, to a yellow into the reds. And I'll let you, we can adjust that scale or add different colors or whatever. We might want to highlight if this equals critical. We can add the same color scale here, although medium would catch two different color scales. That's up to us to decide. And now here's that publication URL. So now I have one click away everything I need to know about this vulnerability, all of them. Very incredible. And in the Postman, it will take us to that publication URL as well. Let's just take a quick look at that. I haven't confirmed this yet. Since I've added that hyperlink, let's see what it's done to the Postman. And we want to try to consume this as an API. So let's go get the Merlin JSON. Well, that's the JSON. Here, if I go here now to the root, it has all of the hyperlinks there that I could follow. I see that's the HTML page. Well, it's all there, right? So anyhow, lots of ways for our developers and our users and our operators to consume it. So now let's move on to recommended release, and let's have some fun with that. I just couldn't help myself. I wanted to pretty that up and make it, like a true gradient dashboard of our vulnerabilities. So let's move on. All right, moving right along, we're going to move into the software suggestion, also known as the recommended release API. Now, to quickly show you this in Postman, and again, I want to point something out. I'm sort of cheating here. The actual version that we get back, the PID, the part ID that this API uses, well, the part ID from the Nexus, the virtual 9K, it's not working, or I don't know what it is. This identifier here. Somebody from Cisco land could tell me what the right virtual ID is. So I just picked an equivalent platform. It's a 9500 Nexus 9K. And I don't know if my token's still valid. No, let me go get a new token. So let me get a token here. And let me go to my recommended release and update that. And here we go. So for this 9K, they have the product list and the different suggestions, right? So 9508 for ACI, and I think most of these are ACI, so this might not be the right product ID, but it's good enough for the example. So, and you get all this great information. Well, let's run it through Merlin, through PyATS, and through a Jinja template, and make a web page out of this information. So I'll show you the code real quick. The Jinja template looks like this. And we pick out the various pieces of information and we run our for loop. And what I'm actually doing is some logic here to say if release format 1 does not equal our installed version, make the cell red and say no, we're not compliant under this compliant field. But if they match, say yes, we're compliant, meaning our running version matches the gold star recommended release. The PyATS, or the, I'm only using PyATS as the framework to make this a test. But really what I'm using is the Python requests.post to go get a token, and .get after I have a token And with my .get, I'm passing it the headers, my OAuth headers that I've set up somewhere else here, right here, authorization and my OAuth token. So then I make that my home page as the last step, and I create those files. I call this from a script, recommended release, where I run this job. I copy in the files. I turn on Apache. All of this working backwards references the Docker file for recommended release, where we copy all of this into our container and run that shell. So let's turn it on and let's have a look. I already have my home page running, I believe, but let's do a build. And build no cache recommended release. Now again, I want to show you here before I run this. I am cheating, but you don't have to cheat. And in Merlin with iOS XE, it doesn't have to be a cheat. Right here, I'm passing it the hard-coded value. What this could be in a real world is the value parsed from show version. Right, I'm still parsing show version here. One of those keys would be the PID on a real device, and that PID is what we would feed this API. Just to highlight that again real quick. So let's bring this up, and we'll watch it run. I don't think I'm printing anything to the screen in this case. We'll bring up recommended release. Now it's going to connect and parse show version and then feed some stuff. Not in this case, it's going to feed the hard-coded value to the API, but it's still valuable as an exercise. So now that I have my Apache up, right from my home page, I can go in here to the recommended release, and now I have a table of the recommended releases for this platform. If it's the suggested release and the major release version, the name of the release, the recommended version, the version we have on our device, and whether or not they're compliant. We have the raw JSON of all this information. We have it in a CSV file. Let me just check the CSV file to make sure it's good. Yeah, it looks good. Maybe an extra line here at the top I can get rid of. I'll fix that. Anyway, looking really good. So what are John's next steps? This is the Docker world. Now I'm not going to reshoot the video, but I'm going to go through the process of making these Kubernetes pods. Once I have them as Kubernetes pods, we can restart them every minute or every day or weekly or whatever cadence we want. We can just run them as pods, as services, as deployments in Kubernetes. So let me commit this to my Docker. Right, I'm going to put variables in and comment some stuff out that you'll have to turn on, and I'll update the README file. And then I will go ahead and transform them into Kubernetes, and I'll show you that as a Kubernetes service once I'm there. All right, thanks again for sticking around. All right, we're all set to bring this into Kubernetes. So I'll just quickly show you here. This is my Kubernetes system right now, and I just have the home page up and running as a deployment, as a pod, and if we look in the network, as a service. There's my homepage service. Now if we go back to the code, I've taken everything that we already had in Docker. Nothing's changed, except in the Docker compose file, which I also bring over, I've run the command compose with a K, Kubernetes command, convert, and I converted these two Docker compose sets of instructions into the full-blown deployment and service. Now I have my node port and my node port forwarding IP, port, for both of these. And I also have a cron job, which I have commented out, that's only going to restart those two services. Now let's go ahead and bring them in. So this is a kube apply F command, and then our PSIRT deployment and service and recommended release deployment and service. And they're going to come up right away. And now if I go back to my VS Code, or even from here, if I do kube control, get deployments, we're going to see we have our 3 deployments. And now let's get our services. And let's do what says O wide, I believe. Yeah, a little bit more information. And let's do the same for deployments, O wide. right? All this great stuff. And now let's do our pods. And then pods, wide. Right, so they all have an IP. We have the age. Lots of great information here. So now let's go check our Kubernetes service with, local hosts. 30,000 takes us to our home page. Let me just kill all this noise. And then here is our PSIRT. There's our PSIRT with our highlighted colors. And our JSON links, our API is up. This is great. Our publication URL for the more rich details. That worked, by the way. I just clicked ahead. Yeah, I'm not cheating in any way here. All these links work. Wonderful, wonderful, wonderful. Now I have the recommended release as well. And, they're not compliant, and we've already explored all this. So now let me load in the I would need to add a timestamp field of our own to show that this is being refreshed every minute. There isn't really anything to show us that this is being refreshed by the minute. But just for the exercise, all I need to do now is to load in, kube control apply F, and it's cron job.yaml. Cube control apply F cron job.yaml. So that's been created. So now if we get our pods wide and let's get cron jobs, we have that cron job there. Let me clear the screen. So there's the cron jobs and there's the pods. So we should see a new pod come up that's going to reset the PSIRT and the recommended release. Let's see if this happens. Now, I may want to add, and it's not a bad little thing, I won't do it for this video, but add a column to those, to all of our artifacts that is the timestamp it was gathered. That might be good information. So let's see here, is it restarting? So that's creating the restart container. We can see that here. And that's going to take a second to spin up the deployment restart container, and then we should see the time on these two pods go from 3 minutes. We should see them actually get destroyed and restart. Just have to be patient. Just have to be patient. A minute feels like a long time, I know. But, okay, age 51. Still creating that container. Maybe what I should do is build that container. Maybe it's building it this first time because it wasn't pre-built like my other containers with Docker. So I could pre-build it and then it won't have to do this creating. It's downloading Cube Control or whatever it's downloading from the internet. That's what's taking so long here. It's just clicked for me that I should pre-build that. All right, here we are. They're starting to terminate now. And you can see that they've already restarted our new ones. So that would refresh these documents every minute. Maybe a minute is a little aggressive for this type of information. Every day, every hour, whatever you want. But so those are two of the Cisco services in the cloud that are just incredible in your toolkit. What's the recommended version? Am I running the recommended version? Are there any security flaws in the version I'm running? How severe are those security flaws? We live in a very dangerous world with ransomware, state-sponsored attacks. Staying on top of this information is very important, and it's not just the security team's job. It's the network engineer's job. It's our job first, make a secure network. Yes, IT security can help us and is very valuable to the team. But if we have a security by design, if we can automate little functions, little artificial intelligent robots that can go out and say, make a phone call to the CISO because we have a severity 9 vulnerability that just opened up in the last minute, wouldn't that be incredible? Let's take artificial intelligence and put it on our team. Let's get these robots on our side. All right, thanks again. Stay safe, everybody. I hope you're enjoying these. And again, they're all open source. They're all available for you. Bye.